On. So today's class was really that fifth Thursday of the month, which normally we would do the bring us your energy code questions, but we did that a few months ago, and so we thought maybe it would be a good opportunity to again break out and break down the REScheck reports. So if you have questions about REScheck or ComCheck to a degree, make sure you bring them up, put them in the chat, raise your hand, put some Q&A together. We're gonna, like I said, we're gonna take a walk through the process, how we evaluate it, what we're using it for, and then what we as plans examiners and inspectors are doing with it, as well as designers, how it gets used. And sometimes, especially in larger or longer projects, sometimes it can become less helpful than maybe was intended. So I appreciate Andre doing the class last week, giving it, doing a lot, talking a lot about the different resources that we've curated. If you did have questions about that, or you didn't get that list of resources, please feel free to reach out to us through the helpline, and I know we can email that back out to those that might have missed those resources. We'll also try to, we're talking again, we got an update yesterday that they're not done yet with our new website. So once we get that, maybe we can put those links there. Digression to a degree, but more importantly, whenever I talk about any type of code or think about code in applying it as a plans examiner or a building inspector, I always think about why. Why are we doing the things that we do? And I think that's one of those fundamental reasons for evaluating RESchecks, right? Why are we doing the REScheck? And once we understand why we're doing it, then we can better figure out how to accomplish it. And when we think about the building code and the energy code specifically, we understand that what we're looking for is an effective way to conserve energy over the useful life of a building that provides the level of flexibility. And the REScheck, ComCheck systems are the epitome of flexibility in energy conservation, right? It's that, and we'll talk, and again, but I don't want to get too far ahead of ourselves, but at the same time, everything we do is try to be more flexible in what we expect out of buildings, understanding that energy considerations are key to community resilience and community sustainability, right? And when we start talking about how a community responds, or I got into a little bit of a disaster planning kick for a couple days. When we start talking about how communities grow and communities are successful, it's really a lot of times based on this understanding of how much do we need of a particular resource, how much water, how much sewage capacity, how much energy, what type of energy. All those are important things to understand when we start to get into understanding individual projects. Now, we know when we start thinking about a project, a lot of times I like to remind us that energy compliance begins on paper, because when we have an accurate enough set of details, we're able to appropriately monitor and install those components. I like to keep life simple, so I've always told you that I keep it those four basic concepts: the building thermal envelope, the air barrier, the mechanical systems, and the power and lighting. When we talk about residential, we've been doing a lot of commercial lately, so I think that's why I kind of thought maybe a REScheck would be the way to go. And we understand that while energy compliance begins on paper, it also requires a level of inspection. And so we can't just look at a report and say, you know what, hey, they gave me a REScheck, I'm done, I'm out, right? We look at more than just that. We still have a responsibility. I was talking with a state on Tuesday that was looking at updating from the 2015 to the 2024 and series of building and energy codes. And one of the conversations we had was, one of the statements made by one of the contractors is, well, this will be great for plans examiners, because for the city, because once we do this and if we do it, and they brought it up, they said if they do a REScheck, then the city doesn't have to do anything. There'll be no inspections. There'll be no, we'll just build it that way. And it's like, no, no, hold on, put the brakes on. Just because we receive a REScheck doesn't mean that it's a way to say we don't have to do anything with the project. We don't do anything as plans examiners. We don't do anything as inspectors, right? It's not a here's my pass, and I'm my get out of jail free card, right? It's really a system that we have to do both plan review and inspections as part. It doesn't circumvent that process. And in that, and when we think about, again, our visual bypass checklist and those kinds of things, we're doing inspections. We're not getting a free pass just because you used a particular tool in determining compliance. Now, I always say this because I think it's important to remind ourselves of, when we look at that code edition, make sure that those projects are coming in with the New Mexico Administrative Code, the appropriate, NMAC references, right? I've told you before, I'm a little bit leery when I start to see plans that come in and say, hey, we're using the 21 model code. I did a project yesterday, a significant fourth series of revisions, and it's a large hotel project, and it was very interesting because in comments and at the beginning of the process, again, it's a little bit digression, but in the beginning of the process, we laid out, you've referenced the 2018 codes, the jurisdictions applying the 21, make sure you make those reference changes. So in version 2, they did. Version 3, they made some more changes. And version 4, which I saw yesterday, they went back to the 2018 version references. So it's like, what all changed? And now we have to look at that project. I think is close to 1,200 pages of actual designs, right? Or design pages. Not necessarily every one is I call relevant, right? Depending on the fixtures, the finishes, that kind of thing, the furniture location. There's parts of that are important for different reasons. But again, when we go so far and then all of a sudden we flip back, that's why it's important, I think, at times to make sure we're using the right code edition. And like we've said before, if someone's crossing that line from Texas into New Mexico, or from Colorado, Arizona, when we think about those different contractors and design professionals, we want to make sure that they're referencing the appropriately applied building and construction codes. So there's my hobby horse. I got off of it. But then we have to identify that compliance path, and we know that within residential there are basically 3 to 4 compliance paths, right? We generally see it in really a set of 3. There's prescriptive, which is when we're going to be following the expectations of the code itself as a whole. We see that in commercial. Then there's performance, which is total building performance in the 21 version, which is, again, a calculation of the operating expenses of that building over the course of a year, taking into account all of the equipment, all of the systems, right? All the insulation, all those components. Then we calculate a dollar value for that annual energy consumption, energy use, and then we compare that to a reference standard. We did something very similar in commercial. We've talked about that before as far as our building performance path. And then the third option in residential is that energy rating index. Now, the energy rating index is very similar to our total building performance calculation. However, what it does incorporate is instead of doing dollar for dollar comparison, it's a grading scale, right? We're going to be looking at it as a point on a scale. Where is your building and where's the reference standard? And did you beat that? Is your score better than, equal to, or better than that reference standard? We've talked about ERI before. I think I've got a slide or 2 in here about ERI and how it's different in its reports from what we see in REScheck. But one of the things that I think is really important for us to understand, and maybe I could have clicked through these slides to tell you all this, right? Performance, or prescriptive, performance, and then ERIs. One of the things I think is important to understand is a lot of times we use nomenclature, we use phrases, words, and names that aren't really reflective of what we're doing, right? We'll throw the handout into the chat one more time. So there are a lot of times when I will be discussing with the design team, and they'll say, well, we're using performance. Okay, what rating system are you using? What software are you using? And they'll say, well, we're using REScheck. REScheck is not a rating system. REScheck is not a performance measuring software. I've met with P&L last week, and they're trying to make some changes to REScheck. And one of the things we talked about is, I told them, I said, well, actually, I'm teaching a class in a week next week. I'll see what people say about REScheck. So if you have comments about REScheck, please make sure that you put them in here so that we can have that conversation. I can take that back to P&L and tell them what doesn't make sense, right? But I think, when we think about what REScheck, ComCheck really are, is they are ways to calculate the building thermal envelope. For the most part, that's really what they're doing. They're looking for that. They come on, when you see it referenced, it's under section 402.15, where we talk about that total UA alternative component alternative, right? Because we're averaging the envelope, the bubble itself, and saying, okay, how do we trade within the bubble as part of our prescriptive compliance? Let me see what we got here in the comment. Consider orientation. Did not previously. Yeah. So, and we'll talk about that because it does change in the 21 orientation, especially in ComCheck. In the 24 version of REScheck, it starts to come into a little bit. If you input in those values and don't add in your orientation, then it will kick you out as an error. So we'll talk a little bit about that, Francois. But again, when we think about those compliance paths, a performance report is going to take into effect more than just the envelope, right? It's going to tell me how that equipment operates. It's a question of what is the efficiency, what's the actual efficiency of that, not does it meet the minimum expectations of the code. And I can trade a lot of things off depending on my efficiency, my lighting systems, and those kinds of things. You can take advantage, and I make this point a lot. In the 21 adoption and 21 edition of the code, we really focus a lot. Most of our energy considerations are on lighting, right? But you can make the argument in a performance rating system that by controlling those, slow down here. Prescriptively, all I have to do is have 100% high efficacy lamps and put in some dimmers, right? That's what the code says. I can employ or utilize a digital lighting control system and a demand response control system that says, hey, and I'm going to say this, and you guys know I love my children, but for some reason they tend not to remember that when they're done playing video games, the TV doesn't need to be on, right? I don't know how many hours my television, especially during the summer while they're home, how many hours my television is on when it doesn't need to be. Or again, when they leave the Xbox, we have, as you guys know, I have three boys and one princess, and those boys we have expanded our energy use to incorporate televisions in multiple rooms and 3 Xboxes and all that goes with that. And again, when they're not using those gaming systems, guess what? They're still on. So they're using energy. So if I went with a performance method, I could actually install receptacles that say, hey, when we're not using that, it's off. Or which is almost like it'd be a blessing, right? To say from 11 a.m. until 7 p.m., they're off. You won't use them, right? So you can calculate the amount of savings that can be and then demonstrate that in a report. That's not something REScheck is ever going to do. Digression. Same thing with ERI. ERI extends beyond just mechanical equipment and lighting controls. It incorporates, decisions you make on dishwashers or clothes dryers to, again, calculate how your building will perform against a standard. So again, I want to make sure we're really on that understanding that REScheck is about the building envelope, not a performance rating or performance measure. That's one of those things I said to P&L the other day was there's a lot of misunderstandings about the role because we allow it to be called in the code a performance alternative, and it's not. It's a total it's a a total area weighted calculation of thermal resistance, right? And that just doesn't sound as cool. So you start to see, I think it's in the 24, we call it the percent, it's the PEAC, the percentage of envelope area. I can't remember. So anyhow, but there's some concepts maybe moving that direction. But I digress nonetheless. So when we start thinking about, but regardless, in all our compliance paths, we go back to this idea that the envelope is one of those four pillars of our design. And so after we've evaluated the code and the path, we go through this process of evaluating the envelope. And I think we talked a little bit about that during our inspections conversation. We'll get more into envelopes later. But really what the code tells us is that we need to provide this information, right? We need to know where it's at so we know what we're looking for, right? When I think about the envelope, even within the envelope, I like to keep it simple. So I think about four things when I think about the envelope. I think about the envelope location. I think about the insulation material. I think about the fenestration. And then I think about air leakage as a whole when in relation of that envelope, right? I'm looking at a building, and again, that's just the way my brain thinks. Get out my laser pointer. What is part of my envelope, right? Where is it? I see that I have wall, which tells me there's insulation somewhere as part of that thermal envelope. I see windows, so I have to think about them as fenestration. And then I think about the whole thing. How does it perform when it comes to air leakage controls, right? And so again, the code provides us some direction on locating the thermal envelope. Designating it on those plans is critical. Again, I go into a lot of plans and really hit this big that proper designation and depiction is critical to me understanding what is part of that system, especially when you get into some larger designs, because it could impact where we put mechanical equipment or how we see that continuity, right? So that we know where everything starts. So when I go out to do an inspection, am I looking at this interior wall? Are we going to condition the garage? Not condition the garage? Are we conditioning above the garage? Those kinds of considerations come in when we start talking about the location. But when we start getting into the question of insulation materials, that's when REScheck really comes out, right? When we start thinking about those lists of tables that we find in section 402 and those specific insulation expectations, we know that there is a variety of things that we're looking for, both in the plans and when we go out and do our inspections, right? We've talked about this. I think we talked about this to a degree when we got together on the 17th and talked about the overview of insulation. And again, this field guide is something that should be available online. I'm hoping it's available there. If it's not, please reach out to me and we can send you the installation or inspection field guide that we've put together. But one of the things, again, we're looking at those different systems on the foundation, the frame, the walls, above grade, below grade, and then the roof system and those other elements like garage sunroof separations, ducts, and all those kind of things. But when we think about what we're looking for, where we're looking, and what we're looking for, we understand that insulation has a purpose. A lot of times we talk about the flexibility to use different materials, right? Not everyone has to use a spray foam, right? Not everybody wants to use a denim, right? Material, because we know that different materials insulate. They have different installation expectations. Again, questions about the amount of potential strapping that may go for depending on where we're placing it in a design. There's a lot of considerations to go into what material we use, but we really break it down to these four basic concepts of rigid, spray, batter, blow. And so when we think about that method, again, we're trying to provide flexibility and not say every building. I'm dealing with this with a code adoption where they're talking about making it to where everyone has to use spray foam. And my comment to the committee was, if you do that, you're going to make people upset. Well, spray foam is new. It's cool. It does all these things. Yeah, and there's always going to be one person that says, I think mineral wool is safer, healthier, better, easier. You can't limit everybody to one type of material. The same way we don't in traditional construction, right? We don't say everybody has to use yellow pine. Why? Because there's so many other options. The moment you say there will be no other building material but yellow pine used, then you're going to get all the concrete people calling, all the steel frame guys calling, all the people that use different hardwoods, right? Different design types, straw bale, hempcrete. All those guys are going to, all those people are going to come out of the woodwork and say, hey, what about us? What about us? Right? So we have to be innovative, flexible. We have to be innovative and understand that what the insulation is really doing is resisting heat transfer, whether it's at a different level based on different materials. It's really all doing the same thing. It's just how well, how effectively, or how efficiently do we want to get that done? And so we know that within the general area, now we know that, yes, across the state, there are a wider range of climate zones. But when we think about the big three, I like to call them in most of New Mexico, we think about climate zones 3, 4, and 5, right? And so when we think about those, we see that those different assemblies are provided different minimum R values. We've talked about before the difference between R values and U factors. Remember, R values is a singular material and its thermal resistance rating, which is an inverse of its U factor. The U factor, I'm going to give it, I'm not going to ask the question. We should all remember from our trivia quiz, which came first, the chicken or the egg, the U factor, the R value. And the answer was the U factor. Remember, it came out in 1701 with Sir Isaac Newton calculating the amount of heat that transfers through a material over a given amount of time. And to make life a little easier, back in 1945, we created the concept of the R value so that as we reduce heat transfer, our U factor goes down, right? That's why it gets lower. Whereas the R value, because we wanted something that sounds better, when you say, hey, I've got an R40 versus an R50, right? We know as many people marketing would say bigger is always better. That's why I buy a venti and not a large, right? Or a grande. And so we're talking about coffee there for those that aren't in the parlay, right? The parlance there. But we want that bigger coffee. We want that bigger insulation number. So we created the R value in 1945, which literally, like we see the equation there. Instead of its watts per square meter Kelvin, it's calculate the U first and then divide it by 1, right? So you still got to do the U calculation. But again, that's why when we see the 21, and I kind of glazed over this, when we think about the 21 R value table, it's now section R402.13 versus when we look at the U factor, it's R402.12. So this table comes before the R value table because we understand there's flexibility. Because when we tell somebody, hey, you can use an R20 in the wall, or you can do an R13 plus 5, or you can do just R15 continuous on the outside of the wall, then they'll come back and say, well, what if I want to do an R7.5 plus this? Well, we're not going to put all 1,000 different variations in this table, so we gave you a U factor. And so you can use that U factor to calculate how does my wall match in relation to that value, right? And again, we can do that math to calculate that U factor. And we've talked about that before, how we can add different cavity insulations in order to get to different variables. And that's ultimately what the REScheck, now that we've talked about all that, that's really what REScheck's doing. It's doing the math behind this calculation. Because remember what we're doing was we're adding all of the thermal values at the stud and calculating that against the framing factor, how many studs there are in that wall. All right, and that's a mathematical equation. If it's 8 feet long and it's 16 on center, then we know how many walls we're going to need, how many studs are in that spacing. And then we can do the same thing for the cavity, right? We average those numbers, calculate it out, and we get to a U factor. And again, by replacing those thermal values, those cavity values, we can go from a 57 down to a 4.043, right? And so then we can look at our tables and say, hey, what am I going to do now versus what I've done in the past, right? If we look at what the code has really done over the last couple of years, we've got 21 here, which is what the state is currently on. We've got the 2015-18, which is some previous additions. And we see that the U value or the R value has really not changed significantly, right? Look at section 3 or climate zone 3. We went from 20 or 13 with 5 continuous to 20 or 13 plus 5 continuous. And we just added an extra option for somebody who says, I don't want any insulation on the inside. I want it all on the outside. I'm going to buy an R15, insulated panel, and use that as my sheathing, right? What we've done in some of those larger, or as we get cooler in our climates, we start to get more insulation to, again, control better the impacts of the exterior environment on the interior space to reduce the amount of heating, cooling equipment or material capacity we need. But ultimately, like we see here, the U factor stayed the same in that. And in this one, it dropped to the 0.045. Now, I'm going to remind us, I'm going to go back a page. Although we see here we have R30 or 20 plus 5 or 13 plus 10 or 20 ounce continuous. We have those 4 options. We also have these other 2 options that would have been under that 0.45. So they would have been compliant as well. So see, we can add other options into a design. And that's what brings us to section 402.15, which is that total UA alternative, right? And again, a lot of times people, the code will call this a performance alternative, a component performance alternative. And so that's usually where we get confused. But what it's really doing is we're using REScheck, ComCheck to do that math calculation that we saw 2 slides ago. And so we can go to the website, we can log into the REScheck, we can get into this. Now we've done the deep dives, and if we want to do that, we can do that some more here today. But really what we're doing is we're laying out a framework, right? One of the things I talked to P&L is really getting that. ComCheck is a little bit further along than REScheck and what it can provide. And so one of the things we talked about was making the ability to save and do multiple projects and share those and give that little bit more flexibility there. One of the things that P&L is looking at is, again, maybe making it more, providing a jurisdictional landing page, to where as a jurisdiction you would have your own login and you could go in and you could see the open RESchecks in your area so that you could kind of monitor things during plan review until it's been approved. So again, there was some talk about that. If that's something you might be interested in, reach out to me, let me know, and we can pass that along, or I can give you their information directly. But when we start thinking about what REScheck we're doing, we're actually developing and building a wall design, right? We're going to pick, is it wood frame, steel frame, concrete? We're going to make that selection based on what we're looking for. And then we'll also be able to put in the amount of the gross area of that wall system, right? This is when we'll add in. So we'll take the whole area. So if I say the entire wall, I use my wall as an example, is 2,288 square feet. And when what I start to do is I start to build that wall, and we'll talk about fenestrations in the context of it. But I get into that wall and I say, okay, I'm going to have this 2,288 square foot wall that's going to be wood frame, 16 on center. It's going to have 19 cavity and 1 continuous, because I'm going to have vinyl siding that's going to have a little bit of insulation behind it. So it's giving me, according to the manufacturer, 1R of thermal resistance, right? Not a whole lot. That would be the 1 BTU per hour is being slowed by that insulation. Not a lot, right? And so what we're doing is we put in those values and we can apply them and build the wall that we're going to be using. Now, one of the things I see happen a lot of times is we build it at first, and then somewhere in the process, especially in longer, larger projects, when we start talking about those R2s, R3s, R4s that follow the residential, or if we're talking about this in commercial, it happens there too. We see the breakdown of we moved some things, but we didn't change the REScheck. We didn't change the COM-check, right? We didn't update it yet. And so we may be having an older version of it, of the wall design in COM-check or REScheck than what we see in the plan. And so sometimes that's a point of contention or a comment that I'll send out. I'll show you one of those here in a second. Right, but we can also, again, develop, design, and list those different assemblies. Again, here's our basement wall, right? It's telling me how I'm going to insulate it. I'm going to insulate on the inside, the outside. What's my depth of insulation? I'm going 2 foot, 4 foot, 10 foot? What am I doing? Right, so those are different options there. Now I can put in that R value. I can put in that U factor, right? You think U factor was back here. So one of the things that I like about REScheck, COM-check is after I've designed my building, which if you can't, I'll zoom in so we can maybe see that middle section there. We put in that wall. We see it listed at the very top, that wood assembly, wood frame, 16-ohm center. We put in my gross area. We put in the 19 cavity, 0 continuous. It calculates for me right then and there that U factor, that area weighted U factor of 0.06. When I start to look at, and then I start putting in the windows, I've got a glass door, and I've got a basement, I've got a solid door, I've got some vinyl windows. I put in their sizes, square feet, their U factors, solar heat gains, those variables there. And we start to develop what is really the building. Now, what it's taking is the 2288. It is going out of that 2,288 square feet, it's going to reduce the 36, 18, and 412 square feet of windows within that wall system, right? Now, so I can add multiple designs. So I may have I have one side of the house that has I got French doors here. I've got one side that's got sliding doors and a service door. I've got a front door, so there are going to be different wall designs based on the number of windows and all that. Sometimes I'll see where where designers, because you can tell the system's not going to say, hey, you don't have 4 walls. It's going to allow you to put in, I'm just going to do all the walls at once, all the windows at once, and then it's not going to give me a good solid example. You can do that mathematically, it still comes out the same, right? I like to have it designed because if I change something, maybe, and again, this is my house, so on the north side of the building, we have a thicker drywall and thicker insulation because it faces the road. Whereas on the south side, we don't care about that as much. It's a more rural atmosphere. So so I can have different variables. And so by adding a little bit of insulation here, I can maybe deduct or reduce insulation on the other, trade it off on the other side. Digression. Again, I've got my basement, I've got my crawl space, the square footages, how deep, and what kind of insulation we're doing on those. So again, I build the design, and then I run a compliance. I run the quick REScheck, right? The check compliance. At the beginning of this process, we can type in the code. We can change those codes from a 2018 to a 2021 to a 2024. So again, you kind of see here, I'm still having the example on the screen is the 2018, even though we're using the 21. But when I actually go to run so I can check the compliance, I can say, hey, forgot I got the wrong section. Let's change it and then run it again, get my report. I just ran it a little bit ago. It's 38% better than code. And so when I run that report, I can generate out a REScheck, right? And there are certain things I'm going to evaluate. So that REScheck, again, is going to give me a compliance certificate, and it's going to give me some checklists. As a plans examiner, when I get this report, I am not immediately looking at this green bar and saying, yeah, well, that's the first thing I look at. Verify, hey, it looks like we're using the UA trade-off, they're compliant, right? I can see the level of their compliance. But the thing that I'm going to notice real quick is that when they go to the code, I verify the code. Okay, we're using 21 IECC. I look at the location, and I'm a little bit questioning, right? Because Amarillo, Texas is not technically Clovis, New Mexico. It may be close. It's definitely not Hobbs. It's definitely not Las Cruces, right? So I'm going to have some question as to whether or not this is the right design. I'm going to look at the construction site, right? And I'm going to see, wait a minute, they're building this in Maine. What? I'm again, this to me is one of those opportunities to say there appears to be some inconsistencies between the location listed in the project section and the construction zone or the construction site. I mean, those would be obvious things. I'm going to verify that I'm looking at the right type of building. Obviously, we're doing single family. We're doing new construction. I've got it in my square footage of total area. It has calculated a glazing area based on what I've put into the system. Now, remember, the code is really not designed. Prescriptive compliance is not necessarily the best option when I have a 30 to 40% or more glass building. So if I've got somebody who wants that beautiful view of the mountainside and they want a lot of glass, I'm probably going to have to go with an actual performance, not a REScheck. Again, it tells me my climate zone. It's telling me what days there are. It tells me, again, some other questions. It's going to ask me, we know that we're not required to have in New Mexico under the adoption. We're not required to have additional efficiency options. But if somebody wanted to put one in there, they could, right? That information would be provided there. Those are things I'm going to immediately check. And then I'm going to start to walk through and say, okay, well, and again, here's another, we're looking at the same thing, but now it's 2015. Thanks for resubmitting, but just sent me again the wrong information, right? So again, we can really easily verify that, how those buildings perform and what we're evaluating. One thing I want to show out, and one of the reasons I put this one in here was to show you that same design. All I did was change the code. I went from 16% better than code to 26% better than code by going back a cycle or a cycle or two, right? So again, we can design the same building once and then just change that compliance path. If we're going to I'm going to say cookie cutter build that same building envelope over and over. So again, we can save it, we can change it, we can do those things and reprint it. Again, after we verify the top half of the report, now that I've fixed it, it's actually this Hannah Court in Hobbs, New Mexico. Now I can start to evaluate what is the actual envelope they're proposing, right? They're showing me a flat roof or a scissor truss with 38 cavity and 10 continuous, right? They're showing me a 19 wall with a 1 continuous, a 13 base, a 3.3 basement, and 15 continuous on the outside of that basement, and again, a crawl space. They're giving me these variables. I'm verifying cavity versus continuous, and then I'm going to take that information and take it to my plan, right? We can also see again, they got the fenestration information there. Here, normally the way you'll see this is the proposed versus the required by climate zone, by compliance path, code year, and all that. And then you'll see, at least on windows and doors, you'll see the solar heat gain coefficient over on this side. We'll get to that in a minute. So when I take that cavity continuous insulation question, I go to now I start to identify where my insulation is. I know where the envelope is that I need to look at. Now I need to start asking the question, what are we doing with it, right? And so again, remember, this is all about being flexible. It's not about saying, hey, you gave me a 19 and a 1, and that is not one of my prescriptive options, right? It's really not even a question of, does that 19.1 at 0.056 match my 0.045, right? I'm not comparing it to the table. I'm comparing it to the plans, right? I want to make that clear. When I compare this value, I'm comparing it to the plan, because they may have done more in another area than to make it compliant. They're 16% better than the code, because what we're looking at is the total area weighted average for all the building. Really what they're probably doing, to be honest, is going to be this whole basement crawl space. They've over insulated it, and so that's giving them a lot of freedom to do some other things. And so again, we can see those designs, right? Let's say they were required to have a 60, right? Versus a 24. This is the model. This is not what was adopted in New Mexico, right? But if it was a 60, then we could see how close do we get. Now, 60 cavity insulation is the same as also correlates to a 0.024 in that ceiling design. We see here, I've used a 38 cavity and a 5 continuous, and I get the same U factor. I've got a 20 cavity, 21 continuous, same U factor. So again, I have right here on the screen 3 options to get R60 equivalent insulation in that wall design, right? We could talk all day about different options. So again, I'm not comparing it to the table. I'm comparing it to what's in my building plan. So when I look, I'm looking for 9 and this one here is in 19 and 5. I look at my insulation. My insulation says per code and specs. Great. That doesn't help me at all. Unless you put in a table that says what you're doing, these two don't correlate, right? The table, the code tells me one thing, and this CommCheck is telling me you're doing something different. So I'm going to need some kind of a table in the design that references back to what the CommCheck says. And when I'm doing that inspection, again, I'm looking for that same thing. I'm less concerned about what type of insulation, as long as you show me the cavity has 19, right? And there's a 5 continuous in this design. So again, I can start looking at that floor space, right? Am I looking at, let's see what we got here in our, we're showing we don't even have a floor in this page, but we got a 13.5 on that crawl space. Well, we're supposed to have 10. So we've done 50% better on that crawl space, which is why it's giving us so much flexibility above, because we understand the impact of the ground and on the interior heating, heat gain and heat loss of that building, right? Same thing with that basement. So again, we're gonna use those inspection lists. Again, I'm kind of jumping around here a little bit. That inspection checklist is created by the designer, and so it's, to me, it's, unless they're filling it out, it's usually not helpful. Most designers don't know to do that, and most designers don't do it because most building departments are still going to, if you're going to use the thermal bypass checklist. So why create this, right? When you go to print off your report, you can actually select to not include the checklist, and it makes life easier when it's 2 pages instead of 11, right? I digress there for a second. But then again, part of that CommCheck is we're going to identify in there those different window values. And so again, I want to verify that those values are reflected by what's in the plan, right? So I'm seeing a 0.32 wood frame window. I go over here and I see a 0.37, a 0.29, a 0.77. None of those match. So I'm going to send a comment. There appears to be some inconsistency between the U factor identified for the wood frame windows and the information provided on page 4, right? That's what I'm looking for. I've got a vinyl window here. I've got a wood frame at 3.32. I got a vinyl here at 0.24. None of that is reflective in what's on the actual plans. So again, I need to have that consistency. Once I get a consistency from front to end, that's when I can move forward, because that's going to affect what I'm looking for in the building, right? If I'm looking for a 3.2 and I see a 3.0, you did better than what was designed. I'm not going to have as big a fit as, well, but you were supposed to put a 2.4 and you put a 3.0, right? You're supposed to put a 24, you put a 30. And so then we're going to have more heat loss than what we originally intended. It's not the right window. Why do I care about all that? Because it affects my mechanical system, right? In CommCheck, REScheck, you can list the mechanical equipment, right? But this is just listing it. It doesn't evaluate anything. CommCheck's the same way, right? When we go through and we list this information, you can add that assembly information, tell it whether it's a furnace, a boiler, a heat pump, an air conditioner. You as a designer, they input this information. that doesn't alleviate my requirement to go and actually inspect and evaluate it, right? I'm going to review it and say, I'm going to look for a manual J. We've talked about manual J's. We'll talk about mechanical next week, like starting to get into that conversation. But the concept of what's inside the REScheck is helping me decide what I'm going to provide as far as mechanical equipment and making sure I have the proper design. I'm going to throw this one in here. I know we got a few minutes left. I trust you all to not know who this is, any of these designers, and don't hold anybody responsible. Again, this is for educational benefit only. I say that right. So here's a REScheck that I got recently. I want to show you again. Look at the list of all the different assemblies in this particular design, right? What they've done, we'll zoom in here a little bit. So we've got wall 9. We've got wall 10. You know, some have different locations, some have cavity only, continuous and cavity, some don't. We have different windows, right? We have windows identified here. We see their solar heat gain, or not, their U factors. We see their, I don't see their solar heat gain listed there. So see, we can have that information, and I'm going to ask some clarifying questions, right? What's going on? We got some walls have 19, some walls have 21. Especially when you start talking about modeling, you may have that. This is the perfect thing for remodels, right? Where I've got a wall that, hey, I'm not touching that wall. It's an R13, but I'm going to do everything else in the building, so I might as well just recalculate the whole building. And because I got that 13, I might have to put 21 instead of 20 somewhere else to get a fully compliant building. We can talk about existing buildings later. And especially when we start talking the more recent 24, 27 editions, we get to that kind of thing where it says, hey, if you're doing an alteration, you need to alter the whole building, right? Or you need to evaluate the whole building to determine. This is going to be one of those reasons why it's really important to go back and say, what insulation do I have in the wall? We don't know. We didn't put in the certificate, you know, that the code requires. We didn't keep a list of what's in the wall. So I know what's in my walls because I'm an idiot and I actually checked it out, right? I'm not going to say I misused, but I had access to the inspection records, and so I've got copies of my inspection records to say, hey, what was installed in my walls? So I know I've got R13, 13 in these in my southeast and west walls. I've got 19 in my north wall because they wanted that sound separation as well, right? So again, we can see all those things in there. What's important to understand, like we're talking about here in this design, is when we look at the manual J, right? We understand the calculations. I'm going to zoom down here. I know we're not talking about manual J's, so don't get air sick as I traverse this section. But what I want to show us, if I can find it, is where we start talking about, shoot, I might have overshot it. The wall designs. Maybe this isn't a good example. I thought this was the right one. I might have to apologize. But one of the things I like to do whenever I get my comm checks and my REScheck, my res checks and my mechanical heating cooling load calculations, I'm evaluating what is that thermal heat. It's not in here. What are those thermal loss values, right? Does that manual J have the right and consistent insulation with what's going in the building plans? A lot of times, especially like I said, longer projects, bigger projects, there's separation. The mechanical engineer and the architect are two different people. And so they sent me a REScheck, and then they didn't tell me we changed some things. And so this wall no longer does what it's supposed to, and I'm going to have the wrong sized equipment going into the building. Again, we've got another example of, I'll throw this one up there. This one is a multifamily building, right? They went with a simple attempt. They got the north wall is 21, south wall 21, east wall 21, right? They've done all those things. They've told me what the floor is going to be R10 or 4 feet below. When I go to the plans, I can evaluate that. When I went to the plans, what I noticed was that wasn't what was in the plans, right? What was in the plan was the inclusion of a half-inch or a 3/4 inch of continuous insulation. I just want to make sure that you're getting all the value you can, right? And so they came back and they did they adjusted it. And so they went from being right at 2% better to 8% better. That gave them a little bit of breathing room when it comes to how they install it and what flexibility they may need in the installation process. So again, that's something to think about. And again, they can impact. I had one the other day where they had the roof system was listed as 60 on the manual J. It was 38 on the building plans. That affected their mechanical sizing, right? So those are things that we have to think about. And again, in that process of evaluation, we're looking at that heating load calculation in order to determine, is this the appropriate material, the appropriate mechanical system? And so again, I'm calculating a heating load based on what this building is being built to with. And so again, if we're telling the mechanical design team, whether that's an actual engineering firm or a mechanical designer, or if that's going to be just I don't want to make it downplay it, but whether you're just going with an HVAC company that's doing its own manual J calculation, if you've given them the wrong information, if they're operating under a belief that this building's envelope is going to have R21, but your REScheck shows you're having R13, then that's going to affect how efficiently that equipment is going to be able to do it. It's going to affect the heating load. So when I go to select a piece of equipment, and I'm not going to get a piece of equipment that matches with what I'm doing in order to get compliance. So again, we talked a little bit about, if you have any questions, let me know. We talked a little bit about ComCheck. Like I said, you log into ComCheck, very similar process, right? We're going to evaluate the year, the climate zone, the project size. To me, this is the same thing like when we talked about the square footage of the house. One thing that we'll also be doing is also evaluating the project, right? If we're doing ComCheck, we've talked about ComCheck before, back in, I think, April. But one of the things that with ComCheck, you want to make sure it's the right type of building. That we didn't start out with this being an office, and then all of a sudden we turn it into a retail space, right? That those calculations may be different, that the size is the same, right? It starts off that this is going to be a 25,000 square foot building, and then all of a sudden, well, we added a couple things. It's really going to be about 40,000. Is that going to affect anything? Well, depending on what you expand, it could, right? Especially when you start looking at something. I had a designer last week I was talking to. They said, if we're over by 10%, then we actually will reduce insulation to get closer to 0 to 1. We want to be 1 to 2%. And I said, well, hey, that's up to you. I don't trust anybody's level of consistent installation to work on that skinny of a measure of success, right? What if they don't put in 13 continuous, they only put in 10? That's going to affect you. Might not be able to see it today, but you will get that phone call later when somebody comes back and says, well, wait a minute, I was looking at the records, you were approved at 13, but the material that's installed says R10. How did that happen? It just happens, right? That's not the information we want to see or provide, right? So again, we're going to verify project, we're going to verify that compliance rate. We'll do the same thing. We're going to be evaluating cavity versus continuous. And kind of like Francois was saying, with the 21 version of the commercial code, especially, you have to put in those north-south designations. the code will, specifically because it gets into the impact it has on fenestration. Because if you remember fenestration in the 21, it really gets into that idea of, the south face, north face, west face. And so again, that's one of the things I think is important. Can you ask if the state amendments can be adjusted into the program, i.e. eliminate? Yes. So one of the things that you can do, and if that's something we need to, Brian, I think that might be a larger conversation. Yes, REScheck, ComCheck do provide state modification. They provide it, and you can do that. You can also, like you said, eliminate, recalculate. I've seen jurisdictions do both ways. Some have just gone to P&L and said, hey, we have this special modification. Can you just adjust the model? I've had other jurisdictions that say, well, we'll just pre-calculate and say that, we will accept a project that is 3% or 5% worse than code. So you can turn in one. That's why, again, to me, it is less a function of this green bar. And I know one jurisdiction that says we want to they went the opposite. They didn't eliminate the below grade slab insulation. They added insulation. So they were required at least a 7% better than code, or it doesn't pass, right? But I think you can do the same thing. And like I said, when you start to affect that 21 insulation value, then yeah, you can when you choose a different R value for the ceiling, choose a different R value for whatever it might be, you can correct for those things. And so what I would do is, again, either we can talk about, I can double check. I'm not sure that Minnesota's actually has reached out to P&L. I can check with Martine and the staff up there to figure that out. I'll do that, and then I'll get back with you. And again, I talked to P&L. They're more than happy to do those modifications, especially something that's they consider simple, right? Where we're not doing this, we're just moving this back, to an 18. So absolutely. And again, what I would maybe do is, if anybody has any questions, feel free to reach out to me about it. We can help with that. Maybe if we need to come up with a stopgap measure in between, if we do have some major changes. That I didn't see anything that was like, earth shaking when I ran it, but like we said, when we dialed back that 60 to 49, 48 in the ceiling cavity, it seems to work when, if I put an R40 in there. Now you've seen the building that I designed, it worked and still was better than what code would provide. One thing that ComCheck gives us in addition, and I know I got a few seconds, it gives us some other things like the mechanical, interior and exterior power and lighting. Again, those are going to be things that are specifically user defined. Again, it's not what it's not really doing a whole lot to calculate other than doing some simple math, adding things up. It's not confirming. That's what we do in plan review. And again, we've talked about ComCheck before, but this was an opportunity to kind of dive a little bit more in the REScheck. Again, if you have extra questions, please feel free to put them in the survey, email me, email the team. If you don't have my email, let me know. I guess you can put that in the chat or email. You should be able to, but you can always email us at the nmhelpline@shumscoda.com. Again, upcoming classes, we're going to talk about mechanical, swimming. I think Hope said this. Hope's going to be teaching class on swimming pools and the impact there. Make sure you use the survey. If you've not already given us your AIA number, make sure you put it in there. You can always reach out to us for different help, support, information like that through the helpline. You can check out the website, find our different contact information, and our newsletter should go out either today or tomorrow for the next 2-month series. But always feel free to reach out. And then if you just want to put in joshua.harmon instead of NM Helpline, that's my email personally. So again, you guys have a great day. Be careful. Stay warm. Stay out of the rain. Tim, stay out of the rain. And you guys have fun. I'll see you guys next week.